Okay, let's just dive right into this. Welcome to This Explainer. I want you to imagine, just for a second, that you're standing right at the starting line of a massive marathon. You've trained, you're ready, but you wouldn't just sprint the very first mile at top speed and then collapse on the side of the road, right? Of course not. You need a strategy. You absolutely have to manage your energy for the long haul. Well, sitting down to take your Cambridge A-level mathematics exams, and we're specifically talking about the 9709 syllabus today, is exactly the same thing. It is literally an intellectual marathon. Today, we're going to zero in on one of the most critical, high-stakes concepts where students are just bleeding easy marks. I'm talking about energy, work, and power, specifically that golden formula, power equals work over time, which also equals force times velocity. We are going to use this one specific topic as our master key to unlock a universal, bulletproof exam strategy that applies across the board for syllabus codes 0580, 0606, 4024, 4037, 4040, and of course, our main focus, 9709.
Now listen closely to this direct quote pulled straight from a senior examiner. They said, "Most students lose easy marks on energy, work, and power, but after this, you won't be one of them." I am adopting the senior examiner's playbook today. I want to pull back the curtain and show you exactly what happens behind the scenes when your paper is being graded. Because here's the reality, getting top marks, it isn't just about memorizing raw math facts. No way. It's about knowing exactly how to present those facts to the human being marking your paper. Today we're going to decode the exact presentation and analytical framework that Cambridge examiners are practically begging to see.
So here's our roadmap for today's session. 1. We'll cover core analytical foundations. 2. The procedural framework. 3. The transformation. 4. An interactive workshop. 5. Top examiner warnings. And finally, 6. The final system.
Section 1. Core analytical foundations. Let's start by looking at a really dangerous gap between having basic knowledge and demonstrating true analytical depth.
I want to introduce you to our two test students. We'll call them Alex and Sam. Now, both of these students actually know their formulas, but spoiler alert, neither of them is getting an A-star. Let's look at why. Alex suffers from what we call superficial breadth. Alex looks at an energy, work, and power question and just panic dumps every single thing they know onto the page. They overload it with raw math facts. Every kinematic equation, every definition of work done, it's all there. But there's absolutely zero analysis connecting those formulas to the actual scenario in the question. And then there's Sam. Sam is just constantly rushing against the clock. Because Sam is rushing, they completely miss the specific command word requirements. They don't realize there's a massive difference between the command to calculate and the command to evaluate. And because of that panic, Sam ends up with terrible, unreadable formatting. These are the two absolute most common ways candidates completely fail to demonstrate connected, conceptual understanding. And before we fix Alex and Sam's mistakes, I need to remind you to subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Let's make sure you don't fall into the same traps they did.
So what do the examiners actually want to see from you? Well, the 9709 assessment objectives form a sort of pyramid. At the very base, the absolute bare minimum, you have knowledge and understanding. You know what a formula is. Next step up is the application of formulae. This is where you can actually substitute numbers into, say, power equals work over time. But the absolute peak of that pyramid, the thing that separates the standard passing grades from the elite top-tier marks, is analytical and evaluative depth. You have to understand that Cambridge explicitly prioritizes this analytical depth over superficial breadth. They honestly do not care how many formulas you've memorized. What they want to see is how you take one single formula, like P equals FE, and use it as a tool to solve a complex, multi-stage physics problem.
The crucial concept that ties all this together is something called connected conceptual understanding. If there's a holy grail for Cambridge mathematics candidates, this is it. It's defined as your ability to take a fundamental mathematical principle, like the very concept that power is the rate of doing work, and seamlessly transfer it to a totally unfamiliar context. Imagine the exam throws a curveball, like a car driving up an inclined plane against a variable resistance force. Can you logically evaluate the alternative methods to solve that? Because top-performing candidates, they do this instinctively. They don't freeze up when the context changes. They rely on their connected understanding to bridge the gap.
Section 2. The procedural framework. Now we're moving from theory into the exact technical methodology that examiners are looking for.
Consider this 5-step procedural framework your absolute lifeline for literally any energy, work, and power question they throw at you. Step 1. Deconstruct the question. You need to physically underline the command words. Step 2. Extract the relevant data from any texts and tables provided. Step 3. Select your analytical framework. Ask yourself, Are we using the work-energy principle here, or is this a purely kinematics problem? Step 4. Execute the math with crystal-clear notation. And finally, Step 5. Present your final answer with the correct terminology. I promise you, if you follow this exact recipe to the letter, you are mathematically bulletproof.
Section 3. V transformation. Let's see exactly what happens to your score when we apply strict conventions to maximize those marks.
Okay, major examiner alert here. We need to talk about the method mark strategy. The rule is simple. Process equals points. I cannot overstate this. This is arguably the biggest open secret in the entire Cambridge grading system. Marks are awarded for your process. You absolutely must show you're working. Let's say your final answer is completely tragically incorrect just because you dropped a negative sign somewhere or your finger slipped and you mispressed a button on your calculator. If you've shown your work, the method marks can literally save your entire grade. Let's look at a real-world transformation. Take a student who just writes down a wrong final answer with 0 working shown. The result? 0 marks. It's a complete washout. But now, take another student. They have the exact same wrong final answer, but instead, they actually show the P equals FV framework on the page. They show that they extracted the force. They show they attempted to multiply it by the velocity. The examiner sees that process and, boom, the method marks are saved. The red pen turns into green check marks. This is exactly how you build an unbreakable safety net under your exam performance. Now stop scrolling, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries, and you need to join them right now so you never miss these essential strategy sessions.
But to actually guarantee you get those method marks, your presentation has to follow some really strict exam conventions. Proper headings must be utilized. The correct terminology has to be applied. You need to choose appropriate formats for your equations, and clear annotation absolutely must be provided. Think about it. If you annotate your force diagrams clearly, the examiner doesn't have to guess what you were trying to do. You're guiding them right to the points they want to give you. Section 4. The Interactive Workshop. All right, it's time to put you on the spot and test your data interpretation skills in real time. Welcome to Challenge 1, the data scan. You're against the clock here, scanning through this data for time, work, power, velocity, and force. What is the core relationship happening here? Look closely at the progression. Notice how the force remains perfectly constant at 10 newtons. And look at power. It is quite literally just force multiplied by velocity. 50 equals 10 times 5. 100 equals 10 times 10. If you can train your brain to extract this trend instantly under exam pressure, you have completely mastered the procedural data scan. Awesome! Let's move right into Challenge 2. I want you to find the flaw in this written statement. The power of the car increased because it went faster. Read that to yourself carefully. Why on earth does a statement like this lose marks based on Cambridge's critical analysis requirements? Well, I'll tell you why. It is entirely too vague. It completely lacks any specific mathematical terminology. It just carelessly assumes a direct relationship without even bothering to cite that the resistance force remained constant. An examiner reading this sentence will give it absolutely 0 points for analytical depth. Why? Because it's just a descriptive, colloquial observation. It is not a rigorous mathematical evaluation. So how do we fix it? To fix a flawed paragraph like that, you need to use this comparative analysis checklist. This perfectly mirrors the Peel framework: point, evidence, explanation, link. First, you must identify both similarities and differences. Second, you must use proper comparative connectives. Third, you have to support every single point with hard mathematical evidence from the data. And finally, you draw conclusions on relative importance. A perfect A-star answer would look like this. Assuming constant resistance force, the power output is directly proportional to the velocity, as evidenced by the formula P equals FV. Therefore, an increase in velocity necessitates an increase in power output. Do you hear the difference? That is exactly how you secure top marks. Section 5. Top Examiner Warnings. Let's look at the top 3 mistakes pulled directly from official Cambridge Principal Examiner reports. Pay close attention, because these are the top 3 exam mistakes that cost students easy marks on power, work, and time questions every single year. Mistake number 1. Answers are simply too vague. As we just saw with the car example, examiners are begging for specific mathematical details. Mistake number 2. Forgetting to check format and presentation. Messy, chaotic working simply means lost method marks because the examiner can't follow your logic. And mistake number 3, answers are not specific to the provided context.
Let's say the question involves a heavy tractor pulling a massive load up a steep incline. Your analysis absolutely must mention the component of weight acting down the slope. You can't just slap a generic P equals FV formula onto the page and completely ignore the specific physical reality of the context they gave you.
Now you might be wondering, how are you supposed to remember all of this under intense pressure without just relying on dry rote memorization? You need to use the visual story method. Don't just stare at a sterile formula on a whiteboard. Picture it. Visualize the car grinding its way up a steep, muddy hill. It is actively overcoming massive air resistance and the pull of gravity. The engine is absolutely screaming. That is the power. The tires are physically pushing against the rough road. That is the force. And the needle on the speedometer is slowly climbing. That is the velocity. By connecting the abstract equation P equals FV to a really vivid, contextual visual story, you encode it deeply into your memory. This ensures you can pull it out and deploy it in any unfamiliar context the exam throws at you.
Section 6, the final system. Let's wrap all this up and build your ultimate success blueprint. Your mathematics success blueprint relies on 3 absolute, non-negotiable rules. Rule 1, command word decoding. You have to know exactly what the verb in the question is demanding of you before you write a single number. Rule 2, PEL framework application. Make your point clearly, provide solid mathematical evidence, explain the concept thoroughly, and link it right back to the specific context of the question. And Rule 3, the time management matrix. You have to pace yourself like a marathon runner. Do not spend 20 minutes panicking over a simple 3-mark calculation. You must dedicate your time strictly relative to the marks available. Here is the reality. Students who actually implement these precise mathematics strategies see an average improvement of 2 full grade boundaries. That is literally the difference between walking away with a C and celebrating an A. But that kind of massive transformation only happens if you practice consistently alongside explainers just like this one.
So, I'm going to leave you with this final thought. Go look at your own past papers today. Are your practice answers truly specific to the context, or are you just brain-dumping formulas hoping something sticks? What is your actual target grade? And more importantly, what specific changes are you going to make today to guarantee you achieve it? Drop a comment below right now with your target grade for mathematics and the biggest challenge you're currently facing. Our team reads and responds to every single comment. And here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acexams_IGCSE to excel in your Cambridge examinations. Like and share this explainer with your study partner, and don't let another exam pass you by without a strategy. Ace the Exams, your Cambridge success starts here.